Now I will take the numerical problems regarding with this magnetic effect of the current. There are number of numericals, that is known end of the numerical problems, but I will take some special one, and also I will tell you the numerical problems that were asked in NEET exam 2021. So now let us have the numerical problem. The numerical problem that is asked is based on the conversion of galvanometer into the voltmeter and the ammeter. Mainly this is to be asked. So first is a galvanometer gives full scale deflection for 5 milliampere current. Its resistance is 99 ohm. Convert it in number 1 ammeter of 5 ampere range, second voltmeter of 5 volt range. This is given to us. I have told you the conversion of galvanometer into the ammeter. For conversion of galvanometer into ammeter, what we have? We have the current Ig equal to I into S upon S plus G. This is the formula. Ig is the galvanometer current which gives the full scale deflection. I is the range of the ammeter which is to be converted. S the resistance of the shunt, and G is the galvanometer of the resistance of the galvanometer. So here Ig, this is equal to now 5 milliampere, and this is equal to 5 into 10 raised to the power minus 3 ampere. I, this is now your 5 ampere, and this G, this is 99 ohm. You have to find S. This is our question. So now I put all these values in this formula. So Ig is equal to your 5 into 10 raised to the power minus 3. I is equal to 5. S, this you have to find. S or G is equal to 99. This we have to calculate. So now you can see that this 5 and 5 will cancel. So we will have S plus 99 equal to 1000 s. This will go on this side, so this will be positive, so it's 1000 s. So 99 equal to 1000 s minus s. So this is equal to 999 s. This is equal to 99, or s equal to 99 upon 999. So you take this approximate to be 100, this approximate to be 1000. So this will come out to be 0.1. 0.1. This is now so much. So we need a shunt of 0.1 ohm. This is our first part. For second, conversion into voltmeter, what we have, R equal to V upon I minus G. This is the formula. So here this V is given to be 5 volt. This is not 5 volt. I means this is not IG. The current in the calorimeter. This is given here 5 milliampere. So this is equal to here V equal to 5 volt. Ig equal to 5 into 10 raised to the power minus 3 ampere. This is not to be so much. So this R equal to V. This is 5 upon 5 into 10 raised to the power minus 3. This is now 99. This will cancel. This will be now 1000 minus 99. So this will give you R equal to 90 ohm. This is not so much is the answer. This is the answer. So thus you can see that here we have the high resistance 901 ohm. Here we have the very low resistance 0.1 ohm. So this is the conversion of the galvanometer into the ammeter and voltmeter. And always remember that whatever the current is given for the full scale deflection, that is always Ig. And the resistance of the galvanometer that is given to be, that is G. And you have to find the S, the resistance of the shunt. And whenever we have to convert that into the voltmeter, then the given range is V. This is now V. Suppose this is made to be now 5 volt range, 10 volt range, 100 volt range, 1000 volt range, then this will be the value of V. Ig for full scale deflection current, that will be so much. Then you calculate the R. How much R is required to convert into the voltmeter? Now I will tell you the numerical asked in NEET 2021. That is based upon the bending moment of the coil. NEET 2021. A wire of length 12A is used to make an equilateral triangular coil and triangular coil of side A. Triangular coil and square loop, each of side A, This is 12A length of the wire. This wire is, there are two pieces of wire of this length. One is wire is converted into the equilateral triangular coil, and second wire is converted into a square loop of the side A. Each has the side A carrying current I. Square loop, both carrying current I. Compare the magnetic moments of coil and square loop. This is the question. तो इसमें सॉल्यूशन में हम क्या करें? इसमें आप ऐसा करें कि भाई एक अपन को ये ट्रायंगुलर कॉइल दी गई है, इस तरह की ट्रायंगुलर कॉइल है। इसकी जो साइड है वो ए के बराबर, दिस साइड इज ए, इसकी ईच साइड इज ऑफ लेंथ ए. It is the equilateral, so definitely this angle is 60 degree. This is now 60 degree. So magnetic moment, how to find this magnetic moment? M equal to N I A. So and the number of turns. So since we are having the length L, so circumference of this one will be equal to 3A. So one coil is of perimeter 3A. So how many number of turns will be there? Here N equal to 12A upon 3A, the circumference, this circumference. So this is now equal to 4. I, the current A equal to, this is not triangular coil, so the area of this triangular coil. So area of triangular coil is now this is now suppose point O, then this distance will be A by 2, this distance is A by 2. So what we have? 1 by 2 base into height. So this is 1 by 2, base is equal to A, base is equal to A, height is equal to so much. This is not no height, this height, like this. So height, that we will take this 1060. This is now perpendicular upon base. So perpendicular equal to base upon A by 2, 1060. So this is equal to A square upon 4, 1060 is equal to root 3. This is now area. So now we put this value here. This is now suppose M1. Therefore, this M1 equal to, now in place of A we write down 4 into I into A is equal to A square root 3 upon 4. So this 4 and 4 will cancel. This is now root 3 I into A square. Now there is another root, which is the square root, like this, each of side A. This each of side A. Each of side A. It carries the current. So number of turns will be how much? Here this M2 equal to, this is now again NIE. Now here this N. Here N equal to 12A upon 4A. Perimeter that is now 4A. So this will cancel by 3. So this is now your 3. A equal to A square. The area of this one. So now find N2 equal to, in place of N we will write down 3. This is now your I, this is now A square. Now find the ratio M1 upon root 3 I into A square upon 3 I into A square. I into A square will cancel. And this you have to be now root 3. So what we have? M1 upon M2 equal to 1 upon root 3. This is the correct answer. So this is the question that was asked in NEET 2021. Now question number 3. This is of NEET. This is of NEET that I tell you. This is NEET 2016. 2016. So now we take, here this is given A square loop of side L carrying current I is coplanar to a straight long wire carrying current I as shown in figure, find the net force on the loop। ये क्वेश्चन दिया हुआ तो इसमें फिगर में क्या है, ये आपका एक लूप है, ये करंट इस तरीके से ले जा रहा है, कैरिंग द करंट इन दिस वे, दिस इज नाउ योर ए बी सी डी। यहाँ पर एक और स्ट्रेट वायर है, दिस कैरिंग द करंट आई एंड दिस कैरिंग करंट, दिस इज नाउ डिस्टेंस एल and this distance is L by 2 from this one. Now you have to find the force on this loop. So now solution. Solution to this one is what? That you are given this loop. This is now loop. This carries the current I. This is a straight conductor carrying the current I. This is now length L, and this distance is L by 2. This is now A, B, C, D. So now this current and this current is parallel, so they will attract to each other. So now force here, this is now your F1. Now this current and this current are anti-parallel, so they will repel to each other. This is now your F3, and here the force is F1, here the force is F4. These are the four forces. So net force is how much? Net force F equal to F1 plus F2 plus F3 plus F4. So this is what? The sum of these two, like this. This is not net force. And now this F2 and F4 are equal and opposite. But F2 is equal to minus F4. So what we have? This F equal to F1 plus this F3. F1 plus F3. Now this is our attractive force. So F1 is equal to mu naught. And now we will apply the formula for the force between the two straight conductors carrying the current I1 and I2. Mu naught upon 4 pi into 2 I1 I2 upon R. This is now formula. Mu naught upon 2 pi into, this is now I into I upon distance between them. This is now L by 2. This is now L by 2 into the length of this one, that is now L. This is so much, plus This is F1. So this will be attractive. And now this F3. This is equal to mu naught upon 2 pi I into L, the length, upon ये डिस्टेंस कितनी है, ये L by 2, so this is now 3L by 2, so much is 3L by 2, this is now 3L by 2, so much distance, so this is now 3L by 2, so what we have, this L and L will cancel, and this 2 and 2 will cancel, so this is mu naught I into I upon 3. This is equal to F3. This is repulsive force. This is attractive, and here this will be cancel this one, then this L and L will cancel, or 2 and 2, and this L and L also. So this is now your mu naught I into I upon pi. This is not so much. This is now your pi also. Pi. Now then what we have? This F equal to this is now F1 minus F3. So F1 is your mu naught I into I upon pi minus this is your mu naught I into I upon 3 pi. This is equal to F. So now this is your mu naught I into I upon pi into 1 minus 1 by 3. So this is now your 2 by 3 mu naught I into I upon pi. This is now so much is the force. This is the answer. तो नेट फोर्स कितना काम करेगा उसको लोगे. अब ये नेट फोर्स डायरेक्शन क्या होगी, वो टुवर्ड्स दिस स्ट्रेट वायर, क्योंकि ये जो फोर्स है F1 दैट इज मोर देन F3. Since F1 is greater than F3, so F is towards y x1. This is not y x1. This is now x1. So this is the question that was asked in 2016. So like there are so many questions each year. One question at least is asked from this chapter. So this is a very important chapter and you have to study it completely. So you have to watch the video completely. So this is what about the magnetic effect of the current. So thank you very much.